Welcome everyone to this section on principal component analysis. Our discussions of unsupervised learning have really focused on clustering-based techniques such as k-means clustering, which seek to discover labels on feature data that is unlabeled and has no historical label. That is to say, we have unlabeled data and then we're trying to discover some sort of clustering or grouping that we can label to the historically unlabeled data. So what we're going to do now is shift to another set of unsupervised learning techniques, which focuses on dimension reduction. So what are the motivations behind dimension reduction? Imagine you have a data set with 30 plus features. How would you actually understand the key features? Because visualization and even data analysis have limitations when the number of feature dimensions increases to beyond something like 4 dimensions. Because as humans, we're really limited in our visual understanding because we live in a 3D world, which means as you go beyond 3 dimensions or 4 dimensions, adding in some sort of color component, you're not going to be able to visualize something like a 30 plus dimensional data set easily. So that's where it may be a good idea to actually perform dimension reduction. It will also help you understand what were the actual important features that were explaining the variance. Which means we're looking for 2 main outcomes for dimensionality reduction. One is to understand which features describe the most variance in the dataset, and 2 is to aid human understanding of large feature sets, especially through visualization. Now, here's a really important note when we're talking about dimensionality reduction techniques with unsupervised learning. Dimensionality reduction algorithms, such as PCA or principal component analysis, do not simply choose a subset of the existing features. That is to say, if we have some 30 plus feature data set with 30 plus columns, dimensionality reduction doesn't mean you choose columns 1, 5, and 7 and some sort of subset. Instead, we are actually going to create new dimensional components that are combinations of proportions of all the other previously existing features. And we'll talk about that in more detail when we learn how principal component analysis actually operates. So what are we going to learn in this section? We'll talk about the theory and intuition of principal component analysis, and then we're actually going to manually create the principal component analysis algorithm. Then we'll switch over to utilizing scikit-learn to perform PCA, and then you'll have an exercise project overview as well as an exercise solution. Okay, let's get started. I'll see you at the next lecture.